In this video, I'm going to go into the homework on graphing and kind of help you with a few of the questions so you understand how to use this graphing tool that's in the MyLab Math program. So I'm in the homework on section 5.5. First problem I thought we'd look at is number 13. And you know what you would do if you're doing this completely by hand is a little different maybe than what you would do by using the tool in MyLab Math, okay? So what we're trying to actually do ultimately is graph the function, okay? So we have this y equals -2 sine 2x plus 2 pi, okay? So we know that a equals -2, so the amplitude is the absolute value of that. Okay, so we know the amplitude is 2, which means your sine graph is going to be stretched in the vertical direction, and every point is going to be pulled 2 times as far away from the x-axis. Okay, now, so that's the amplitude. Now, period and phase shift we get from here, okay? And the way we've been doing it makes it a whole lot easier is just to set up the inequality that you know the period for sine is 2 pi. And so between 0 and 2 pi, we get a full cycle. So we're going to adjust that and see what happens. So we're going to come in here and solve this inequality. So we're going to subtract 2 pi. Okay, and when we do that, we wind up with -2 pi being less than or equal to 2x, which is less than or equal to 0. Okay, and then we got to get rid of the 2. So we divide everywhere by 2. And we wind up with -pi being less than or equal to x being less than or equal to 0, okay? So where it used to do everything between 0 and 2 pi, it now does it from -pi to 0, okay? So that -pi that you see right there, this, okay, so this was the amplitude. This right here tells us the phase shift, that it's going to start, it's going to be to the left pi units, okay? Now the period is hidden just a little bit, okay, up in here. So let me go ahead and get you to think about it. The period is how long it takes to complete one full cycle. So you can look at the difference. So the period, let me write it over here, is the difference between the 0 and the -pi. So do you see how that's pi units, okay? So what I'm going to do is go ahead and go back, just kind of remember this, that the period was pi, amplitude was 2, and the phase shift was -pi, then it moved to the left pi. So when we get ready to graph this, what ought to happen is between the 0 and the -pi, okay, that's where you're going to think about your 5 key points, okay? So when we were doing it by hand, we would do these 5 key points. Halfway between those would be -pi over 2. Halfway between these two would be -pi over 4. Halfway between here would be -3 pi over 4. You can add those two up and divide by 2 to get these, or you can look at the graph. Let me stretch that out just a little bit. Let me make -pi over here. So okay. So this would be -pi over 4, and this would be -3 pi over 4, and here's your -pi. So that means one full cycle of the sine graph should happen between there. And so remember how sine starts, normally starts right at 0. What we're thinking about is when you think about those 5 key spots, sine starts with 0, goes to 1, goes to 0 again, goes to -1, and then goes back to 0 again. So if I were graphing just y equals sine of the 2x plus 2 pi, it would look like this. It would be 0 up to 1, down to -1, back to 0, I should have said, then down to -1, and then back to 0. And it would have that happening within those pi units, okay? So that's kind of how we were doing it by hand. Now, if it has a vertical stretch, if it has not a stretch, but if it has a stretch, if it has a vertical stretch of 2, an amplitude of 2, that means this point is going to be pulled 2 times as far away, this point, but these are going to stay fixed. So that means it's going to go up like that. Okay. And then if it's got a negative, like it does here, that's just going to flip over. So what you see in green is the answer. All right, but I want to show you how it works in my math lab, because it's a different than when you do it by hand. They ask you for the amplitude, so you say 2. Okay. All right, now it's going to ask you for the period, and that was pi, and the pi is in the toolbar. Okay, then they're going to ask you for the phase shift, and the phase shift was negative pi. Not equals, but negative pi. Okay. All right, now once you get all of those correct, it comes in and it has you graph it. And so I want to show you how this works. So when you click on the graph, it's going to ask you to pick one of these, and see how this one kind of starts at 0, and it tells you that's the sine tool, and this one kind of starts at 1. So we're doing sine, we should pick this guy. Okay. All right, and then when we click the graph, it'll automatically plot. Okay, so it's plotting the sine graph on here. Okay, if it were not adjusted in any way. Now we're going to adjust it. So we're going to say the amplitude is 2. We're going to say the period is pi. You can kind of see it changing, you know, when you look at it. So the period is pi. Okay. The vertical shift, there isn't any vertical shift. The horizontal shift is the phase shift. So that's going to be the negative pi. Let me see if I can get that 0 out of the way. There we go. It's going to be a negative, and then it's going to be pi. And I didn't see a pi symbol, so I just typed in pi, and that worked. Okay, and then this is getting flipped across the x-axis because the negative out in front. So you don't get to graph it like you would by hand, but you use the parameters to make the changes, and then you can save it and check it. Okay, so I wanted to do a couple of those for you. Let's go and do maybe one more. Let's go look at 17. Okay, so on problem 17, we're doing a cosine one. Okay, so let me get a snip of that. And so let's kind of work through those key things. So y equals 3 cosine 4x minus 2 pi. Okay, so 3 is your amplitude. So that'll be a vertical stretch of 3 units. Okay, and see how it was a positive number, so it's going to be in the regular orientation. Then to get your period and your phase shift, just solve that inequality. Oops, meant for that to say 2 pi. I was thinking 0 to 2 pi, 0 to 2 pi, okay? And then just solve that. So you're going to add 2 pi everywhere, and then divide by 4 everywhere. And so that means what used to happen from 0 to 2 pi, and the way cosine used to work from 0 to 2 pi, is now going to happen from pi over 2 to pi. So if we were doing it by hand, we were doing these 5 key points. We're starting at pi over 2, we're ending at pi. Okay, halfway between those two would be 3 pi over 4. Okay, and then we would do halfway between these. Right, this is the part that you kind of get away without doing, because it's going to help you with that on your graph. So when we did this part by hand, we added these two, okay, and then divided by 2. So we wound up with this being pi over 2 plus 3 pi over 4, which is 2 pi over 4 plus 3 pi over 4. So it was 5 pi over 4, and then we had to divide it by 2. So when we divide that by 2, it becomes 5 pi over 8. So we did a little work on finding the 5 key points, and then you could do the same thing there. So if you're trying to do it by hand, I'm going to add pi, but I'm going to write it as 4 pi over 4, so I have a common denominator. Then I get 7 pi over 4, and then I need to divide that by 2, so I get the halfway point, and that becomes 7 pi over 8. So those are the 5 key points, and then you got to think about what cosine does normally. Normally, cosine starts at 1, goes to 0, goes to -1, back to 0, and then back to 1. So that's what's going to happen here. But this problem asks you for amplitude, and then it asks you for the phase shift. So see that pi over 2? That's the phase shift. That's the horizontal shift. Phase shift is positive pi over 2. So that means that pattern that we see, this pattern that we see, starts to the right pi over 2 units. Okay? And then to get the period, we could have found it over here if I hadn't simplified as I went, but an easy way to do it is just to find out what the difference is between the starting point and the ending point. So that would be 2 pi over 2 minus pi over 2. So the period turns out to be pi over 2, okay? All right, so let's go back to the original graph and get all of this. So the amplitude, remember, was 3. The phase shift was positive pi over 2 because that was the new starting point. And then the period, we didn't get it by looking at the pi over 2. We got it by looking at the difference between pi and pi over 2. But it just happened to be pi over 2. All right, so we're going to go back and do the actual value. So the amplitude is 3. Okay. The period is pi over 2. And at this part, I can enter that. And I can just use the regular divided sign on the keyboard, little slash to do it. Okay, and then the phase shift was also pi over 2. Okay. All right, so now go to the graph. And it kind of helps me out a little bit here. When I go to graph, I'm just going to click on my graph and I can get a tool. And this time, since I'm doing cosine, I'm not going to use the one that starts at 0. Cosine starts at 1. So I'm going to pick that one and just click on the graph, and it puts the basic cosine graph on there. Then I put in the parameters to modify that. So I have my amplitude being 3. My period is now going to be pi over 2. Okay, and then the horizontal shift was also pi over 2. And when I don't have the tool, I just put pi in there and it makes it for me. And I hit the divided by 2. Okay, and there's no vertical shift on this one. Okay, and then once I get that, I can check my answer, and there I've got it. Okay, now let's go ahead and look at one more that involves a vertical shift, so you remember where that happens. Okay, I won't do the 5 key points on this one though. Okay, so on here, they didn't ask me to identify all the different pieces on this one. They're just going to get you to notice the vertical shift. Okay. All right, so, but the amplitude is 3. Okay, and then the 1/4 x is what I would set up my inequality to solve. So I'd multiply through by 4 to get rid of that 1/4. That would still be 0. This would now be all the way at 8 pi. You might notice they already had that 8 pi over there. They'd already thought about that. So there is no horizontal shift. Okay, the phase shift is 0. It's still starting where it used to start. Okay, and then the period is the difference between the ending point and the starting point, and so that's 8 pi. So what happens on this is 0 is your starting point, and you don't finish until you get to 8 pi. Halfway in between would be 4 pi. Halfway between those would be 2 pi, and halfway between these would be 6 pi. And then those are the places where and we're doing sine, where the sine would go through its normal rotation. So that means sine would start at 0, go to 1, back to 0, go to -1, back to 0. Okay. Now, all of that we can do, and it makes sense. It's just you don't have to go through all that work on this. When you click here, okay. Oops, I'm in the snip. I got to go back to the irregular. Let me go back here. So when I go here to actually graph and I click on it, I just need to pick that it's sine, not cosine. So I'm going to pick the sine, okay, and get this thing graphed. So when I do, I'm going to start it. I just clicked on the graph and I started at the origin, at 0, and it went ahead and put that picture on there. Okay, now look, that picture already has stretched. See, the original sine would have only gone up to 1. So if this had been, instead of a 3, had been a 1, it would have only been up at 1. Okay, so it already stretched it so that the normal sine thing happens, starts at 0, goes up, goes back to 0, goes down, goes back to 0, and they had it already be stretched 3 units. So all you're really doing now is putting in the vertical shift, and that comes from the +2 at the end. That's what the +2 at the end, that's not in parentheses with the X part. Okay, so that's going to be 2. And then when you do that, it takes what you had and it just shifts that up 2 units. So I just wanted to show you how that works. Okay, so I'm going to save this. This was just help with a few problems from the 5-5 homework. Okay, so let me stop that video.